In this video, we're going to discuss power and how we can use it to solve different physics problems. So the power is defined as the work over the time or the change in energy over time, since change in energy equals work. So the unit for this power is we have an energy unit, which is a joule, over time. So we can say seconds. And so this joule over seconds we call a watt, or a big W, so that's a watt. So you may have heard like kilowatt or something. So that's what a unit of power is. And another way we can define power is, since we know power equals work over time, and work equals force times the distance, cosine of theta, over time, we have this distance over time piece right here. And we know that distance over time just equals the velocity. So we can rewrite power as equal to the force times the velocity, cosine of theta. And so you may have questions that give you velocity, and you can use that to solve for the power. Alright, so let's do an example with power. So a crane lifts a 500 kilogram block of metal 10 meters above the ground. The crane applies a constant power of 750 watts. How long does it take for it to lift the block? Okay, so let's list what we know. So the mass is equal to 500 kilograms. The distance the block travels is 10 meters. And the power is 750 watts. Okay, so we know the power equals the work over time. And we know the work is just force times distance cosine of theta over time. So now we just have to decide what's actually doing this force that's causing the work. Well, we know the crane is lifting the block. So if we were to draw a quick free body diagram, this force applied, or the force by the crane, is what we care about. That's what's causing the power. So this is going to be the applied force. And since the block, let's say we have our block here, is moving in this direction, the force and distance are in the same direction and they're parallel, so this cosine of theta will just go to 1, since theta is 0. So we can rewrite our equation as power equals the force times the distance over time. And so now we're just looking for time, so we can rearrange the equation for time as the force applied times distance over power. But we're not given the force applied. But we can see from our free body diagram that the force applied is equal to the force due to gravity. So we can say force applied equals force due to gravity, and we know force due to gravity is just mass times gravity. And we have the mass and we know gravity because it's constant. So now we have all the variables needed, because we can plug mg into here using this equation, times distance over power. And so now we have all these variables. So we have the mass, we have gravity, we have the distance, and we have the power. Okay, and if we plug this into a calculator, we get that the time it took was 65.33 seconds, and that'll be our final answer. So that's a quick video on how you can use power to solve problems. Leave your questions down below, and thanks for watching.